The Great Pyramid of Giza is the oldest and largest of the pyramids in Giza Pyramid Complex, bordering present-day in Cairo, Egypt. It is the oldest of the seven wonders of the ancient world and one of the most remarkable monuments in mankind history. Egyptologists conclude that the pyramid was built as a tomb for the 4th dynasty Egyptian pharaoh Khufu, and estimate that it was built in 26th century before Christ, during a period of around 27 years. Initially standing at 146.5 meters, the Great Pyramid was the tallest man-made structure in the world for more than 3,800 years. Throughout history, the majority of the smooth white limestone casing was removed, which lowered the pyramid height to the present 138.5 meters. What is seen today is the underlying core structure. The dimensions of the pyramid were 146.5 meters height and a base length of 230.6 meters, giving a volume of roughly 2.6 million cubic meters, which includes an internal hillock. The Great Pyramid was built by quarrying an estimated 2.3 million large block weighing 6 million tons total. The majority of stones are not uniform in size or shape and are only roughly dressed. The purpose of this video is not talk about history, but simulate the original structure in 3D finite element model and find out the stresses and strains of the material inside the structure. I'm here in SAP 2000 environment. I'm going to try to model the 3D finite element model of the Great Pyramid of Giza. And first, we're going to check the coordinates. In the origin, in the x direction, 230.5 meters. In the y direction, the same. In the top, 146.3 meters high. Define materials. I choose a material similar to the rock used in the construction. At least I try to. Assign solid surface springs. I'm going to use 5,000 kilonewtons per meter per square meter, compression only, phase 4 outward. Apply. Again, assign automatic solid mesh, 10 meters size, each element, close, and we can run the model. The results shows the stress behavior. And we see the most part of the internal structure is in compression. See? And then in tension. I'm going to change the units. Again, compression in most part of the structure. And close to the corners, we see an increase of tension and peaks of stress with much higher values and almost close to the limit of the material resistance. Of course, we could refine the mesh, but the purpose here is not talk about 3D finite element, is to analyze what they were doing. Did they have any idea what they were doing? You see the corner, there are compressions and tensions. and the peaks of tensions. In another view, we see points submitted by 24 kilograms per square centimeter and going to the corners, much higher values. Peaks of stress in tension. The strengths, in some point, we see 18.8 centimeters, close to the middle of the structure from below. In this view, and I ask myself if they knew what they were doing, looking at those peaks of stress. That's what intrigues me. And if they did, who told them that? What its meaning or purpose, we still don't know, and those answers remains unknown. The strains, in the other hand, they're very small, and the highest values are in the corners once more. Perhaps because of the small internal stresses and strain, they're still there. See you in the next video.